Section 7.6 Function Operations. Our function operations are addition, subtraction, multiplication, and division. Here we have two symbolic representations for those operations. We're going to show examples through the video of these two symbolic representations. You can always come back to this slide and review those operations. First example, f of x equals 3x squared and g of x is 2x minus 7, and we want to perform the function operation. Number one, f of x minus g of x. F of x is 3x squared minus g of x, which is 2x minus 7. I need to put this in a set of parentheses because I want to subtract the entire function. Now I distribute, gives me 3x squared minus 2x plus 7. I have no like terms, therefore I'm done. Number two, g of x minus f of x. That's going to give me 2x minus 7 minus 3x squared. Put it in descending order of degree, gives me a negative 3x squared plus 2x minus 7. Again, I don't have any like terms, so I'm done. Here I have g of f of x. I'm going to divide. G of x is 2x minus 7 over 3x squared. I could leave this alone and not simplify any further because I don't have a 3 that goes in each term or an x that goes in each term. You could simplify under each term, though, and put 3x squared under each, which would be 2x over 3x squared minus 7 over 3x squared, which would give me 2 over 3x minus 7 over 3x squared. Both are accurate solutions, but we usually keep it this way unless we can simplify into both terms, because that has to go into both terms. Here I'm going to multiply the functions. F of x is 3x squared. G of x is 2x minus 7. Now I'm just going to distribute. That gives me 6x cubed minus 21x squared. I don't have like terms, therefore I'm done. Let's continue with this example. Let f of x equal 3x squared minus 5x minus 2 and g of x equal x minus 2. Perform each function operation. Here I have f of x being divided by g of x. So let's substitute those values in. F of x, I'm going to have 3x squared minus 5x minus 2 over g of x, which is x minus 2. I need to check to see if I can factor the top to be able to simplify this quotient. So here, let's begin by breaking that into two sets of parentheses, 3x and x, and I can place a minus 2 and plus 1. I can check that by foiling. 3x times x is 3x squared. That gives me a minus 6x, plus 1x gives me a minus 5x, and 1 times a negative 2 is a negative 2, all over x minus 2. Now, I can simplify by dropping the x minus 2's in the numerator and denominator, and I'm left with 3x plus 1. Here I have a negative 2 times g of x plus 3 times f of x. Let's substitute our values in for g of x and f of x. Here I have a negative 2 times x minus 2 plus 3 times f of x, which is 3x squared minus 5x minus 2. Now I'm going to distribute in each expression. That's a negative 2 times x is a negative 2x plus 4 plus 9x squared minus 15x minus 6. Now combine like terms. I'm going to put in descending order. That gives me 9x squared. Negative 2x, negative 15x is a negative 17x. And 4 minus 6 is a negative 2. On this example, we have f of x equals 3x squared minus 5x minus 3, and g of x equals x minus 3. Again, perform each function operation. Here I have a negative 4, f of x plus 2, g of x plus 8. Let's substitute our expressions in for f of x and g of x, and we have a negative 4. F of x is 3x squared minus 5x minus 3 plus 2 times g of x, which is x minus 3, plus 8. Let's distribute in each expression. That gives me a negative 12 x squared plus 20x plus 12 plus 2x minus 6 plus 8. Put in descending order of degree gives me a negative 12 x squared. 20x and 2x is going to give me plus 22x. 12 minus 6 is 6. 6 plus 8 is 14. On this example, I have f of x equals 3x squared minus 5x minus 2, and g of x equals x minus 2, and they want us to multiply both functions, g of x times f of x. So I'm going to have x minus 2 times 3x squared minus 5x minus 2. Now I'm just going to distribute each quantity in my first expression through the second expression. So x times 3x squared is going to give me 3x cubed minus 5x squared minus 2x. Negative 6x squared plus 10x plus 4. That's going to give me, in descending order of degree, 3x cubed, negative 5x squared minus 6x squared is a negative 11x squared, negative 2x plus 10x is 8x plus 4. Our next topic is the composite function. A composite function of g with function f is written as and defined as g of f of x, and can be written as g of f of x. The domain of g of f consists of the values of a in the domain of f, the values that we put in for f, and then we would get an output of f, which would be f of a. Those then become the domain of g. In other words, here's the big point. The output of the first function is the input of the second function, and that's demonstrated here. I'm going to get f of x. I'm going to get an output from f of x. That will then be the input for g of x, and from there, we're going to get the output from that function. So we evaluate the inner function f of x first, and then use those results in the input of the outer function g of x. It is easier if we take a look at an example. Here I have a function f, which is a negative 2x squared. Here I have a function g, which is x minus 1. I want to evaluate each value or expression. Here I have g of f of a negative 3. In other words, I want g of f of a negative 3. So what I want to do first is to determine the value of f of a negative 3. So I'm going to have f of a negative 3 equals a negative 2, and in place of x, I'm putting in a negative 3 squared. That value is going to be a negative 2 times 9, which equals a negative 18. I have an input into my inner function. I get an output from that. That output becomes the input to my outer function. So I'm going to evaluate g at a negative 18. Therefore, I'm going to substitute negative 18 into x minus 1, which is a negative 18 minus 1, and I get a negative 19. That is g of f of x. We also want to determine f of g of x in this example. Therefore, I want to evaluate g at a negative 3 first, which gives me x minus 1, which is a negative 3 minus 1, which I know is equal to a negative 4. The input in my inner function, I get its output. That output goes into my outer function. So I'm going to have f of a negative 4. I'm going to evaluate f at a negative 4. That is a negative 2. X, which is a negative 4, squared. A negative 2 times 16, and I get a negative 32. So you can see I am going to have different values when I have g of f of x rather than f of g of x. Again, I want to evaluate each value or expression. Here I have f of g of 0. I want to start with my inner function first, f of g of 0. So I need to determine g of 0. G of 0 is equal to 0 minus 1. In place of x, I put in 0. I get a value of a negative 1. So the input becomes the output. I get a negative 1. That output now goes into my outer function, f of a negative 1. That is going to be a negative 2. And in place of x, I put a negative 1 squared. That gives me a negative 2 times negative 1 squared is 1. I get a value of a negative 2. Here I have g of f of a half. I want to start with my inner function, which would be f of 1/2. So f of a half is going to be a negative 2. In place of x, I'm going to put in 1/2. That's going to be squared. That gives me a negative 2. 1/2 times 1/2 is 1/4. And a negative 2 times 1/4 is a negative 1/2. That output of my first function becomes the input of my second. So I have g of a negative half equals x, which I know is a negative half, minus 1, which equals a negative 1/2, which is a negative 3 over 2. Again, I want to evaluate each value or expression. Here I have g of f of m. So I'm going to follow the same procedures that I have in the following slides. G of f of m. In place of x, I'm going to put in f for my inner function. F of m is equal to a negative 2 m squared. So when I simplify, it's just going to be a negative 2 m squared. That's my output for my inner function. That becomes the input of my inner function. I'll substitute a negative 2m squared into x, which gives me a negative 2 m squared minus 1. Now I check to see if I can simplify by combining like terms. I can't. Therefore, my solution is a negative 2 m squared minus 1 for g of f of m. Here I want to try f of g of m. So I have my outer function of f. I want to determine g of m first, my inner function. G of m is going to equal m minus 1. My output from my inner function becomes the input from my outer function. So I'm going to have f of m minus 1. So wherever I have an x, I'm substituting in m minus 1. That gives me a negative 2. And for x, I'm going to have m minus 1, and that is squared. Now I'm going to set that up as a product of its linear factors, so a negative 2, m minus 1 times m minus 1. I bring down my negative 2, and I'm going to FOIL. When I FOIL, still needs to be in a set of parentheses, m times m is m squared. My inner is minus m, My outer is minus m. That gives me minus 2m. And my last is plus 1. Now I'm going to distribute with the negative 2. Gives me a negative 2m squared plus 4m minus 2. In my next example, I want to find each pair of functions. Find f of g of x and g of f of x. Let's begin with f of g of x. We already know what g of x is. G of x is x squared. So the input of g of x, I get an output of x squared. So f of x squared, that becomes the input of my outer function. So now I'm going to substitute for every x, I'm going to put in x squared, which is going to be 2. In place of x, I put in x squared plus 1 over 3. Since I can't simplify, that's my solution. Now what I want to do is determine g of f of x. G of f of x. I already know what f of x is. When I substitute x into f of x, I get g of 2x plus 1 over 3. The output of my first function becomes the input of g. Therefore, that will be, in place of x, I'm putting in that entire quotient, which is going to be 2x plus 1 over 3 squared, which I have to write as products, which is going to be 2x plus 1 over 3 times 2x plus 1 over 3. I'm going to multiply across the top and multiply across the bottom. When I multiply across the top, I need to FOIL. That's going to give me first 4x squared, which is 2x times 2x. My inner is 2x, a positive 2x. My outer is a positive 2x. 2x plus 2x is 4x. And my last is plus 1. Over, multiplying across the bottom, I get 9. I check to see if 9 can go into any of my terms above. Since it can't go into any, because it needs to go into all of them, I am done, and therefore that is my solution. Again, I want to determine f of g of x and g of f of x with the given functions. Let's begin with f of g of x. We already know if I substitute x into g of x, I'm going to get f of x minus 4. That's the output from g of x. That's our input for f of x. Therefore, I'm going to substitute x minus 4 into x. That gives me 2 times x minus 4 squared plus 3. I'm going to FOIL this, write it as linear factors. X minus 4 times x minus 4 plus 3. When I FOIL, that's going to give me x squared minus 8x plus 16 plus 3. Now we distribute, gives me 2x squared minus 16x plus 32 plus 3. And when I simplify, combine like terms, gives me 2x squared minus 16x plus 35. Our next one, g of f of x. I know when I have an input of x into f, I'm going to end up with g with an output here of 2x squared plus 3. The output from our f is 2x squared plus 3. That's my input to my g, which is going to be 2x squared plus 3 into my x minus 4. Simplify, I get 2x squared minus 1.